The next step that we have to go through is the model training. Now we have selected our model based on the highest performance comparisons that we have experimented when choosing the right model, as we have talked about doing a comparison between different models to select the higher evaluation metrics that we have seen. So the next step is to train the model on the training data set. This involves fitting the model to the training data so it learns the underlying patterns that can help make prediction. A key actions involved on model training is training the model by using FIT method. FIT method is mainly used to train the model on the training data. Next key action here is the model tuning. Experimenting with hyperparameters like regularization, strength, and logistic regression or number of trees on random forest. Most models require tuning of hyperparameters to achieve the best performance. For example, the decision tree depth, the learning rate for boosting models, or the number of layers in a neural network can significantly impact the model effectiveness. The experimentation and doing model tuning can happen through different functionalities. Two of them are very famous here, and model tuning called grid search CV or random search, which helps finding the optimal hyperparameters of your model. Let's talk about model tuning in more detail. So once you have a working model, you can further improve its performance through hyperparameters tuning. This involves adjusting the parameters of the model to optimize its performance. A key actions that we have discussed and functions that can be used to find the best parameters that fit your or suit your model to be able to find the patterns within your data is different from model to a model. The famous ones here are grid search CV. Grid search CV, what it does, it searches for the best hyperparameters by trying different combination of values. Also, we have random search CV. It's randomly searching for the best parameters to save computation time. Cross-validation. Use k-fold cross-validation to avoid overfitting and to validate the model on multiple datasets. Now, after we have finished from splitting our data, fitting the model, and training our training data into the model that we have selected, and we have model tuning completed using grid search CV, and we implemented all of these hyperparameters. Now it's the time for one of the most important step here, which is called the model evaluation. As we have discussed earlier, experimenting with different data subset can also be useful. For example, evaluating the model performance on balanced dataset versus an imbalance may give you insight into how well the models can handle different scenarios. So after the training the model, we evaluate its performance using the test data, which we have splitted earlier with 20%. Common evaluation metrics for classification problem or classification tasks, including accuracy, precision, recall, F1 score, and the ROC and AUC curve. Let's talk about the most used evaluation metric here, starting with the confusion matrix. Confusion matrix is a table used to evaluate the performance of classification algorithm. It compares the predicted labels by the model with the actual labels from the true data and summarizes the type of classification error made. A typical confusion matrix for binary classification problem looks like an actual positive and an actual negative. compared to the predicted positive and predicted negative. The importance of confusion matrix, it gives you more detailed view of the model performance than accuracy alone. It shows you just how often the model is correct, but also the type of mistakes it's making. It is especially useful when dealing with imbalanced dataset where accuracy might be misleading. Example, if accuracy is 95% of the data is in one class, a model that always predicts the class could still have 95 accuracy, but it wouldn't be effective. Next, we have accuracy, precision, recall, and F1 score. The accuracy is the proportion of correct prediction, both true positive and true negative, out of all of the prediction made. The cons or the cons of going or selecting only the accuracy metric, it's not ideal when you have imbalance classes, as higher accuracy can be achieved by favoring majority class. Next, we have the precision. Precision is the proportion of true positives out of all of the predictions that the model has predicted as positive. It answers of all of the instances predicted as positive, how many were actually positive. The pros here of going with the precision metric, it's useful when the cost of false positive is high. For example, in medical diagnosis where predicting a disease is not present could lead unnecessary treatment. The cons of going with the precision only, if your model is predicting too many positive label, the precision might be or the precision might increase. Next, we have a recall. Recall is the proportion of true positives out of all of the actual positive prediction. It answers all of the actual positive, how many did the model correctly identify them. The pros or the pros of going with the recall is it's very important when the cost of false negative is high. Example, in fraud detection, where missing a fraud is very costly. The con of going with recall, it's if you overpredict the positive class, recall may be high, but precision could suffer. If one score, it's the harmonic mean of precision and recall percentages. It balances the two metric by punishing extreme values when one is much larger than the other. It's good metric when you need to balance between the precision and recall, especially in imbalanced dataset. Next, we have cross-validation. Cross-validation is a technique that's used to assess how well a model generalizes to independent dataset. It helps to avoid overfitting. In simple terms, it's a process of splitting your data into multiple subsets, which called folds, and the training and testing the model multiple times to ensure the consistency performance across different subset of data. Why do we use cross-validation? Cross-validation reduces the overfitting. Cross-validation helps you understand if your model is too closely fitted to the training data or whether it will generalize well to new data. It's also more reliable performance estimate. It gives more accurate measure of model performance compared to a single train or test split. It also uses all of your data. Since every data point is used for both training and testing, you are making the most out of the data. So you don't have to split your data into 20% and 80%. So using cross-validation, it goes through all of the data, but it it separates your data into different folds or subsets. And then each of these subsets is divided into training and testing data splits. It's especially useful when your dataset is small. The final step here is to deploy the model that you have evaluated and you have tested. The time it's to deploy it to make prediction on real world data. We can deploy the model as a web service using frameworks like Flask or Fast API, or use cloud services like AWS SageMaker or Google AI, even Azure AI. The key actions involved on deploying a machine learning model is first to save the model. There are key libraries used to help you saving the model, like Joplib or Pickle, to save a trained model. Next, you create an API endpoint using Flask or Fast API to serve the model as an API. Lastly, we have to monitor and update the model continuously, ensuring the performance and to ensure the update of the model as needed based on new data.